Bonjour, baddies. Welcome back to another video. It's problem number 7 of the 2023 AMC8. A rectangle with sides parallel to the x-axis and y-axis has opposite vertices located at 15,3 and 16,5. A line is drawn through points A, 0, 0, and B, 3, 1. Another line is drawn through points C, 0, 10, and D, 2, 9. How many points on the rectangle lie on at least one of the two lines? Okie dokes. So basically, the way I prefer going about this problem is basically using the linear equations. And if you've never heard of a linear equation, it's basically like a format of equation in which you can use, so basically writing it out, it looks like this: y equals mx plus b, where you can basically, if you know the x and the slope and the y-intercept, you can find out what the y is, and also vice versa. If you know the y as well, you can find x in any pair of points. So basically, I can use this to formulate our two lines here, and I can find their linear equations to see if any of these points lie on their linear equations. So how am I going to do that? Well, in a linear equation, the m basically stands for the slope, the b basically stands for the y-intercept, which is basically the y when x is equivalent to 0. Well, hally-ho! In this problem, it just so happens that both of the points are given, and the y-intercept is already known. So if we go look at line AB first, that was really bad. But anyway, if we look at line AB first, we basically get, if we plug it into this equation, y is equivalent to, if I solve for the slope, which is y2 minus y1, over x2 minus x1, we basically get 1 minus 0 over 3 minus 0, which is basically equivalent to 1/3. Therefore, the slope is 1/3. We get 1/3 of x, and in this case, since when x is equivalent to 0, y is also equivalent to 0 at point A, therefore we just plus 0, so b is equivalent to 0 in this case. And now we look at the linear equation of line C and D. So if we connect this, like so, we go about the same formatting of this, so y is equivalent to finding the slope of this one, goes the same way. So we basically have 10 minus 9 over 0 minus 2, getting you 1 negative 1/2, which also means that that is the slope, therefore negative 1/2 is the slope. So if we plug this in, negative 1/2 x plus, in this case, the y-intercept as 10, as you can see on point C, plus 10. So now that we have our two linear equations, let's get checking. Okay, so if y is equivalent to basically just 1/3 x, we can check these 4 points as we see it. Since it seems that, well, this point seems oddly suspicious and seems like it would probably be in the trajectory of this line, or maybe even close, we can start looking at it first. So 15/5, since 1/3 of x, so x in this case is 15, 1/3 of 15 is indeed 5, therefore this point is indeed on line AB. However, now that we know that this point is on line AB, since line AB keeps going up at a constant slope, there is no way it would hit this point, and every other point is below it. Therefore, we do not need to check the other 3 points. Now we can look at line CD. So line CD, this point obviously seems to be the sussest one, but since this point is on 15, it's not going to be a whole number since it's a negative half of x, so we can start checking the 2 16s instead. So this 16, if we look at it, if we have a 16 in this problem, if the x is equivalent to 16, it's basically going to be negative 1/2 of 16, therefore that would be negative 8. Negative 8 plus 10 is 2. And since both of these 16 points are above 2, neither of these points are on line CD either. Therefore, the only point that is on either of these lines is 15/5, which is only on 1, but that's basically what it's asking. Therefore, the answer is B, 1. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye bye!